Hello, my name is Annie Thompson, and I will be answering question 45 off page 830 of chapter 17, Aqueous Ionic Equilibria. This question asks, what mass of sodium benzoate should you add to 150 milliliters of a 0.15 molar benzoic acid solution to obtain a buffer with a pH of 4.25? Assuming there is no volume change. First, let's identify what the problem has given us. Sodium benzoate has a formula of C6H5COONa, but we know that sodium is always soluble in water, so it will act as a spectator ion, leaving us with the conjugate base C6H5COO-. Benzoic acid has a formula of C6H5COOH, and here acts as a weak acid. We have been told in the problem that the benzoic acid has a molarity of 0.5 molar and is present in 150 milliliters, or 0.150 liters. You can find that by dividing milliliters by 1,000. We can find the pKa for this weak acid on page 731 of the textbook. The pKa is 4.19. We can use the Henderson-Hasselbalch equation to solve this problem, which says pH equals pKa plus the log of the concentration of base divided by the concentration of the acid. The problem tells us that our desired pH is 4.25, so this will go on the left-hand side of the equation. The pKa, 4.19, comes next. We know the molarity of the acid, but we do not know the molarity of the conjugate base. So we will substitute X for the conjugate base and use 0.15 molarity for the acid. We can begin solving this problem for the molarity of the base by subtracting 4.19 from both sides of the equation. Next, we can use 10 to the power of to get rid of the log base 10 in the problem. Finally, we can multiply both sides by 0.15 to find X, which is 0.172 molar. This is the molarity of the conjugate base, C6H5COO-. Now that we have found the molarity of the conjugate base, we need to solve for grams to be able to solve the problem. We know that molarity is in moles per liter, so we can multiply 0.172 moles per liter by the liters given in the problem, 0.15, to end up with moles. Next, we must multiply by the molar mass, but we must make sure not just to multiply by the molar mass of the conjugate base, but to include the sodium, because we are adding this entire molecule into this situation, even though the sodium acts as a spectator ion. The molar mass of C6H5COO-Na is 144.11 grams. From here, we get an answer that we must add 3.7 grams of C6H5COO-Na. Our answer is only reported to 2 sig figs because 0.15 molar is limiting. In summary, we were asked to find grams of weak base added. Given pH and an unchanging volume, as well as the molarity of the weak acid, and finding pKa from the text, we were able to use the Henderson-Hasselbalch equation to find the molarity of the weak base. We used this molarity and multiplied it by volume and molar mass to find the grams that we needed to add to achieve the desired pH.